Okie dokie. So, up here, I'm looking at the 3.3 notes, so I'm on page 12. And up here, I have drawn the same picture he's got on there with some absolute key ideas. Cosine is x over r. Sine is y over r. So what does that mean about x? Well, x is going to be our cosine theta, and y will be our sine theta. When we get to polar coordinates, that will be huge. You'll need to remember that. Now, if this happens to be a unit circle, so in other words, if the radius happens to be 1, then what does that mean about point x and point y? If r is 1, then x and y are just the cosine and the sine. Does that make sense to you? If r is 1. If r is not 1, then x will be our cosine and y will be our sine. Okay, so let's take a look at example 1. He's got a circle with a radius of 4. Here's point P, radius 4, and Q. Which of the following gives the coordinates of point Q? Now, you have got to think about what x, we're looking for x and y right here. And x is going to be our cosine theta, and y is going to be our sine theta. Would you agree with me? Now, what can you tell me about this right here? Which angle is this? Look at where it is on the paper. You're going to have one here and one here. Which one is this one? Pi over 3? So this coordinate would be 4 cosine pi over 3. I don't know what that is. But remember, x is our cosine angle. And this angle is pi over 3. So this x and y is 4 cosine pi over 3, 4 sine pi over 3. Everybody good? So now we're going to reflect that directly across the y-axis. So what is that angle? No, it's not negative. This angle isn't negative. Okay, so keep in mind that. Okay, now remember, okay, this one is pi over 6, this one's pi over 4, and this one's pi over 3, right? Now, we're going continuing on around the circle. What's this one right here in the middle? 3/4. Mm-hmm. What's this one right here? 5/6. Perfect. What's the one I'm looking for? 2/3. Isn't that 2/3? Guys, we got to start pulling this together. Everything on the circle is symmetric. So if we are coming straight across, isn't this the same length as this? So if that's pi over 3, this is pi over 3. This is pi. Pi over 3, excuse me, pi minus pi over 3 would be 2/3. And then what would this one be right here? 7/6. And then 5/4. And then 4/3. Because again, it's pi plus pi over 3. All right, one more time. We'll go ahead and do these over here. What's this one? 5/3. and 7/4 and 11/6. Beautiful. Beautiful. Okay, so now back to the question. Now we know our angle is 2 pi over 3. Our radius is 4. What's x? 4 cosine 2 pi over 3. And y is 4 sine 2 pi over 3. So whatever answer that is, that's the answer. All right, let's look at example 2. What have we got? We got a circle. The radius is r along the line y equals negative x. So does this line make sense to you?
Yes.
And the radius is r. So that's r. And P is down here. And the coordinates of P are 6√2 negative 6√2. Well, a couple of things. First of all, positive, negative, that makes sense, right? Does it make sense that they're the same number? Yeah, because they're on the line y equals negative x. What would be the coordinates of this point? Negative 6√2, positive 6√2? Okay? So, at any rate, here's my triangle. I'm looking at point P, that's the one he gave me. I know the x side, the x coordinate is 6√2. The y side is negative 6√2. And our job is to find the radius. Do not overthink this problem. How are we going to find the radius? Pythagorean theorem. Absolutely. How many sides of the triangle do we know? 2. We can always find the third side of a right triangle with the Pythagorean theorem. So what do I get when I square 6√2? 72. I love it. You square the 6, you square the root 2. 36 times 2. What do I get when I square negative 6√2? 72. So I'm going to add those up and get 144. So my hypotenuse or my radius is 12. You good? Okay. Consider the unit circle level. Now I'm going to erase this one. I had it up here several times. I think we are getting the hang of that. And it's in our notes also. So now I'm going to take my unit circle, and I know these points. Does that make sense to you? Unit circle? Okay, so now I want to know what's the cosine of 0. Now remember, this is 0. Pi over 2, pi, 3 pi over 2, and 2 pi. I want to know the cosine of 0. This is not hard. I erased it. But what's the definition of cosine? X over r. So at 0, do I know x? Yep. Do I know r? Yep, it's 1. Unit circle. So what's the cosine of 0? 1 over 1, which is 1. That is so easy. All right, what's the sine of 0? 0 over 1, which is 0, because sine is y over r. All right, with one more, and then you're going to do the rest on your own. Cosine pi over 2. All right, so now I'm looking up here at pi over 2. Cosine is x over r. So the cosine of pi over 2 is 0. All right, do the rest of them. Jacob, what'd you get for D, the sine of pi over 2? Uh-oh. Uh-oh, you gotta focus. All right, you gotta focus. How do we find, let's help Jacob, how do we find the sine of anything? Sine is going to be y over r. We know r is 1 because we're in the unit circle. At pi over 2, what is my y coordinate? 1. So what is the sine of pi over 2? 1. Okay? Daniel, E.
-1.
Negative 1. Everybody get negative 1 cosine pi? How about F? And? 0. The sine of pi is 0 because y is 0. G, Addie. 0. Cosine 3 pi over 2 is 0. And sine 3 pi over 2, Josie? Negative 1. Perfect. Those angles, I can't remember if I told you or not yesterday, these angles that we have labeled right here are called the quadrantal angles because they terminate on a quadrant divisor line. So 90, 180, 270, those are quadrantal angles, called quadrantal angles. Okay, now, this is where I want you to get out a piece of paper. Because I want to go through something with you, and then we're going to try to translate it over to our notes. You just found, without a calculator, the sine and cosine of lots of angles, the quadrantal angles, 0, pi over 2, pi, and so on. Now we're going to talk about how do we find the sine and cosine of those other angles on our unit circle. We got the top and the bottom and the left and the right. We got that. What about the pi over 6, pi over 4, pi over 3? Because you need to be able to do that. Okay? So one way to do that is just to stop and think about when you were a little kid in geometry class and your teacher drew this triangle up on the board and said this is a special triangle. It is 30, 60, 90. And it's special because the sides are always in this ratio. Across from the 30 is 1. Across from the 60 is root 3. And the hypotenuse is 2. Now, the same triangle situated like this would have the root 3 over here, the 1 here, and the 2 here. Now, that's kind of common knowledge. That's presumed knowledge. You're supposed to know that a 30, 60, 90 has sides in this ratio. Okay? Now, how does that help me? Well, let's look at this one. First of all, 30 degrees, that's the way I learned in geometry, but now I'm a big kid, so how many radians is that? 30 is what? Pi over 6. Remember, what's pi? Pi is 180, so pi over 6 is 30. So what if I said to you, tell me what the cosine of pi over 6 is? Well, this is easy. you can either visualize a circle. X is root 3, y is 1, radius is 2, right? So cosine will be x over r, root 3 over 2. Or, if you'd rather, you can SOHCAHTOA. If this is the angle I'm looking at, which it always will be at the origin, adjacent over hypotenuse, root 3 over 2. See how easy that is? Now, what about, let's say that we want to find the sine of pi over 3. Now, pi over 3 is 60. Pi over 3, 2 pi over 3, 4 pi over 2, 5 pi over 3. Those are your 60s in your unit circle. Well, what would the sine of pi over 3 be? Root 3 over 2? Interesting that the cosine and the sine, cosine 30 and sine 60 are the same. If you look at the triangles, it kind of makes sense. Sine and cosine are co-functions. Co stands for complementary. What did you learn in geometry about complementary? What does that mean? Add up to 90. 30 and 60 add up to 90. So whatever the cosine of 30 is gonna match the sine of the complement. So the sine of 40 will be the same as the cosine of 50. The sine of 45 will be the same as the cosine of 45, which makes perfectly good sense because if our angle is 45, what do we know about these two sides? Our x and our y are the same. So the sine of 45 and the cosine of 45, by the way, that's pi over 4. The sine and cosine of pi over 4 are going to be the same because x and y are the same. Okay? Now, let's branch out a minute. Let's suppose, we're going to get back to your notes here in a second, but let's suppose you have to find the sine of 3 pi over 4. And where is that? Where is 3 pi over 4? Isn't that in the second quadrant over here? And the fourths have what reference angle? What is the degree that goes with pi over 4? 45. So this is your 45 in quadrant 2. Now, are these still 1 and 1 and root 2? Yes. Except what? This one is negative. Right? Which means the sine, oh, well, the sine is still going to be positive. The sine will be 1 over root 2. Once you think about your big circle, here's pi over 4. We figured out that that point is on the unit, well, if I made this a unit circle, made the radius 1, this point would be 1 over root 2, 1 over root 2. Sine and cosine, or cosine and sine. Well, what happens when you move over here to 3 pi over 4? Isn't that point going to be exactly the same, except your x is negative? And then down here, at 5 pi over 4, it's going to be the same, except they're both negative? Guys, are you following?
Yep.
And then here at 7 pi over 4, first one's positive, second one's negative. You just found the sine and cosine of every 45-degree angle in the whole coordinate plane. Cosine, sine of pi over 4. Cosine, sine, 3 pi over 4. Cosine, sine, 5 pi over 4. Cosine, sine, 7 pi over 4. Okay? So let's go ahead and do the 30s now. The 30s. What's the cosine? Root 3 over 2? What's the sine of 30? Well, I need to figure that out. The sine of 30 will be 1/2. So that's the point root 3 over 2 1/2. In your notes, he went through kind of a longer way of getting that. Your notes talk about, right here on page 13, they talk about what is that point. Well, that point is root 3 over 2 1/2. What's this one over here at 5 pi over 6? What will he be? Negative root 3 over 2, positive 1/2. And this one, which is 7 pi over 6, will be negative root 3 over 2, negative 1/2. And 11 pi over 6, positive root 3 over 2, negative 1/2. You just found the sine and cosine of every 30-degree angle. 30, 150, 210, 330. Now, would you see if you can find, let's see, it's one of these problems. Can you do, example 6. Can you do example 6? We are finding the sine and cosine in the unit circle. This is the unit circle. We are finding the sine and cosine for all of your thirds, pi over 3. These are your 60-degree angles, pi over 3. So 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Pi over 3 is 60. Root 3, 1, and 2. What is the cosine of 60? So ca, 1 over 2. So x is 1/2. What's the sine of 60? Root 3 over 2. Now you know the core point. 1/2 comma root 3 over 2. So now you can go around your circle and fill in all of these. So 2 pi over 3 would be negative 1/2, positive root 3 over 2. 4 pi over 3, negative, negative. And 5 pi over 3, positive, negative. So you just filled in that chart in example 6. I did it on the circle, but you filled in the chart. He has drawn this entire picture at the bottom of page 14. Do you understand now how this works? If you know the numbers in quadrant 1 then finding them in the other quadrants is a cinch. You just have to change the signs, right?
Why is it the square root 2 over 2 for all the 45s?
I have been writing 1 over root 2. If I rationalize that, what does it become? So it's the same thing. I know in AP Calculus they do not make you rationalize. I have to check and see if we have to rationalize. I have not been. Okay. All right, let's see. Okay, so now I'm on example 7. He has very kindly given you the quadrant 1 values. That is not going to happen after today. So, one more time. You need to either memorize the quadrant 1 values. That's what they do in every pre-calc room down the hall. You memorize those values, okay? Or, if you prefer, you can remember your little triangles. So for 30, I know my cosine is root 3 over 2, and my sine is 1/2. So I did not memorize the unit circle. I know how it works. I remember my geometry. This is the point for pi over 6. Memorize it or figure it out, but you gotta know it. And the same with pi over 4, and the same with pi over 3. Based on those values in the first quadrant, those are the only ones you really need to memorize. What can you tell me about the sine of 2 pi over 3? Now, what angle are you looking at in quadrant 1? You only have quadrant 1. Which one are you looking at? Pi over 3. So we either memorize 1/2 root 3 over 2, right? Or we figure it out with a 30, 60, 90 triangle. But if that's pi over 3, 2 pi over 3 is over here. So what are those coordinates going to be? Negative 1/2, positive root 3 over 2. We want the sine. The sine is which one? This is a unit circle. The sine is which one? Y. So the answer is root 3 over 2. Cosine 5 pi over 4. So in quadrant 1, which angle are you looking at? Pi over 4. And pi over 4 is the easy one. They match. So either 1 over root 2 or root 2 over 2, depending on if we're rationalizing or not. But now I want 5 pi over 4. Well, where on the circle is 5 pi over 4? Quadrant 3? 5 pi over 4. 1 1/4 pies. 5 pi over 4. So what do you know about these points? For that angle, it'd be negative root 2 over 2, negative root 2 over 2. We want the cosine. Cosine is negative root 2 over 2. All right, we'll do one more together, and then I want you to do a few by yourself. 11 pi over 6. Okay, in quadrant 1, which angle are we concerned about if we're doing 11 pi over 6? Pi over 6, right? So we either memorize or we figure out that for pi over 6, I'm root 3 over 2, 1/2. Now, where is 11 pi over 6? That is the angle I'm actually doing. Where is it? Quadrant 4. So I know that these are going to be the numbers, but in quadrant 4, it'll be positive, negative. I want the cosine, So the answer is positive root 3 over 2. Okay, do we feel like we kind of got it? Okay, I want you to do, we don't have a lot of time, let's try D, E, and F. Let's see if we can get D, E, and F done. Go ahead and use your circle up there. I know you haven't had a chance to memorize or anything yet, and that's fine. You can always do your triangle, figure it out. You got answers, Bryce, what you got?
Starting with negative root 2 over 2.
Okay.
And then negative 1/2. Negative 1/2, I guess.
All right, I don't know if these are right or not. I took answers from Bryce. They're probably right because it's Bryce. But I'm up for discussion. That's what you got? No? Xander?
For the
What are we
same time
drawing?
out, I should have processed something.
Did you miss something?
That one, bottom right one, I got, negative root 3 over 2.
This one?
Yeah.
Okay, so let's go back to our, what he drew for us, our unit circle. Which angle, Xander, in quadrant 1, which angle am I going to use? What's my reference angle, in other words? 30 pi over 6? Pi over 6?
Yeah,
Let your denominator be
Yeah, I
equal.
know where it was.
So pi over 6?
Yeah, good
So
call.
where's 7 pi over 6? Down here in
Yeah,
quadrant.
we
Three?
did coast and stuff.
So it's going to have exactly the same numbers, but they're both going to be negative, and sign is y. I think he's right, negative 1/2.
He is right.
All right, real quick, G and B, or G and H, I mean, G and H, those are quadrantal angles. We already practiced some of those. What's the cosine of pi?
Negative 1.
-1. What is the sine of 3 pi over 2? -1. Perfect. All right, you guys have done a great job. We are going to do a whole bunch more practice with this. Actually, I am not formally assigning the homework, but I think at this point you can do the homework. I threw some tangents into the homework. Sine is y over r. Cosine is x over r. What's tangent? Y over x. Y over x. Remember, tangent is slope. Y over x. Y over x. So, go ahead, feel free to start that homework if you wish, but I won't be assigning it